So today, welcome to MountBlue Prep, the preparatory track for MountBlue. MountBlue is a training company. Uh, so MountBlue Prep is a track to assist you to improve your problem-solving skills. So if you complete 2600 points on Hacker Rank, you can skip the coding test that the MountBlue usually conducts. So this is one of the sessions for it. So today I intend to solve a few questions on recursion. And first to demo you some simple problem on recursion, then we will go to Edabit and pick a problem. Okay, so let's try to solve a very simple problem on recursion first. So I will try to solve a very simple problem, and I will request you guys to send me the answers on chat. I will ask simple questions. So the first simple problem that I want to solve using recursion is something called factorial. I have to calculate the number, like it is denoted by a sign called asterisk, not asterisk. What is it called? Exclamation mark. What is the name for this sign in English? This exclamation mark. I don't know. Okay, fine. So 1 factorial is actually 1. 2 factorial is 2 multiplied by 1 equals 2. 3 factorial is 3 multiplied by 2 into 1, which is 6, and so on. Is that correct? So this is how factorial notation works. Now we can, so this session is about recursion. So we are going to use recursion to solve this problem. So any of you can help me with the logic for this by using recursion? Please write in the chat box. So Ravi is writing n into factorial n minus 1. That's correct. Then some people are messaging me about the boundary conditions. So one thing to notice, and I will write these things here. Whenever we are writing a program, we have to be careful about whether the input is correct or not. So we have to check for wrong input conditions whenever I am writing a function. Second thing is I have to check for boundary conditions when my program should stop. If I don't check for boundary conditions in this case, then my program will go down to minus infinity, which means that it might cause a segmentation fault in languages like C++ or C. The system might go out of memory in Java or some other programming languages. So we have to be careful about the boundary conditions. And the third thing is the regular recursive logic. So looking at the code, the regular recursive logic, people, what they are writing on the chat is this. So here we are clear, like it is very easy. It is 3 into call the program again factorial of 2, then 2 into factorial of 1. Boundary conditions is a bit tricky. What should be the boundary condition? People are writing n equal to 1. Okay, we can do this. We can do n, if n is equal to 1, then return 1. So this is also fine. So far so good. What would be the wrong input conditions? When should I discard the input at all? Like I should not even entertain the input. I return a positive integer or something. So what all things should I check for in my wrong input case? What are the inputs that I should check for? Okay, negative inputs. What else? Are fractional inputs okay? So somebody said negative numbers are not okay. Okay. Are fractional inputs okay? Are decimal inputs okay? Yes or no? Okay. So decimal inputs are not okay. What about string inputs? Boolean inputs? No, right? So in this program, none of the inputs are okay except integer and positive integer. So basically we need to put conditions whether something is an integer and whether something is a positive integer. Cool. So, okay, now this is looking like some sort of a problem that we can solve. We can check the input. So if our function looks like this, let's say I start writing my function here, factorial of input. So I'm writing some pseudocode here. So the first, should we check if input is positive integer, then only engage. If the input is a positive integer, then it goes down. If the input is equal to 1, return 1, right? And then in the end, hey, where did it go? Is there an undo button? Undo. Eh? Okay, it got messed up. Okay, I will write this code in real REPL and we will try to do it. But essentially, I think by now the code is clear. Check for wrong input conditions, do boundary conditions, and apply the recursive logic. So I will stop the share of this whiteboard and share my screen again. So I am going to code in something called REPL.it, which is an online code editor. And I'm opening REPL.it/languages, and I will choose the languages Node.js JavaScript. And it is giving me this editor, and the code will run on the right. So let's write this function. So let's call it let factorial, increase the font size a bit. Okay, factorial equal to function input, and I will just print the input. I will build this function part by part, piece by piece. I will not do a lot of coding directly. And I have to write some test cases to run this function, right? So I will start with all the test cases that shouldn't be there. Like I am a string. Okay. Let's just test it one by one. So I do this, it returns, it prints I am a string, which is the line 2. I can call explicitly this as the input to make it more clear. And I'm not returning anything in this program, so it is printing as undefined in line 5. So I can call it result. So let me run it again. So if the input is I am a string, the result is undefined. The result should be, let's say, return a valid input. So let's write that code here. So one thing to keep in mind, I have to check for a positive integer. So one thing I can do is at least try to practice on the developer tools and see what are the possibilities. So let me check in the console here. And guys, anybody can help me who attended the previous sessions or know the answer how to check for an integer in JavaScript? How should I check whether something is an integer or not? Amar is saying type of. Amar, type of is okay, but type of has some limitations. For example, if I do type of 3, it tells me it's a number. If I do type of 3.4, it also tells me it's a number. So it's not helpful. Nishta is saying use is integer. Nishta, there is a problem. Can I use is integer directly? I don't think so. I have to use is integer as a part of, it's a helper method to number, right? So this is how it works. Now I can check whether something is true or false. It's the syntax is number dot is integer 3.4 false. Okay. So you will get a lot of methods in the number dot, and you will see a lot of helper methods. For example, whether something is an integer, something is a safe integer, is not a number, length, name, parse float, parseint, lot of useful stuff related to numbers. Cool. So we can use this syntax and it will just discard everything else. It will just return false for strings. Like if I do number dot is integer, this is a string, it will return false. If I pass in a boolean, it will return false. So everything it will return false except integers. So this is useful. So if I can put this number dot is integer input, I will return please enter positive integers as input. So let me run this again. It's still showing result as undefined. It should return this, right? Enter positive integers as input. Did I make a mistake here? I don't think so. We do console.log number dot is integer input. Yeah, it's false. Oh, it's false. So my code is wrong. So I have to do not, right? If it is true, then it will return. So I have to check if the number is not an integer, then this code will work. The result is please enter positive. So is this part clear, guys? So if the number is not an integer, then it will return, please enter positive integers. I just added a not sign in front of it. Cool. So I will move out this and let's check it. Let's kind of just check this for other kinds of wrong inputs, like maybe we pass in true. Let's check. Yeah, so still wrong input. Maybe we pass in 4.5. Still wrong input. Okay. Maybe we pass in -4 and it's giving undefined. So we have not handled the case where the number is less than 0 or less than 1. So maybe now it's time to add that extra logic, or the input is less than 1. So for now, let's assume like 0 factorial has no significance. But I think in actually 0 factorial is 1. So I'm just assuming this factorial notation starts at a positive integer. Cool. So we have tested all the wrong input cases. So let me call this wrong input conditions. Now I will have to put the boundary conditions. The boundary condition, if the input is 1, then return 1. Okay. So let me write this test case here. Run it. Cool. So this test case is also working. If the input is 1, the result is 1. Undefined. Now the result for 2, we have not really handled it. We have handled wrong input conditions. We have handled the boundary condition. Now we have to handle the logic. So the logic is, if all of this stuff, we have taken care of the wrong input conditions, boundary condition, we can simply do return input into factorial input. That's it, and the code should work. But it is not working. Why? I made a mistake here. What is the mistake? It went into infinite recursive loop. What is the mistake here? Yes, I made a mistake in the recursion. It should not be input into factorial input. It should be input -1. Now if I run it, so, okay, let me remove this input condition. It is causing a bit of confusion. And just, okay, result we are getting. Let's try this for 3. 3, it's 6. Let's try this for 4. 4, it's 24. And then let's try this for, let's say, 10. Cool. So we have solved this problem of factorial. And we tried to be careful about the boundary condition. Still, we hit infinite loop because our logic was wrong at a particular place. Is this clear, guys? The 3 steps to solving a recursion problem: handling the wrong input conditions, handling the boundary conditions, and writing the recursive logic. When you are using platforms like Edabit, HackerRank, you don't need to worry that much about the wrong input conditions. When you are writing real life problems where users are involved, the wrong input conditions are very, very important, extremely important. Like if you are doing any kind of real world programming. But in Edabit and HackerRank, they generally don't give you any wrong input cases. But you do have to care a lot about boundary conditions in Edabit and HackerRank, or else your program will go into an infinite loop. So far, so good. Can you guys give me any feedback on this? Is it okay? Should I move ahead? Okay. So, okay. So one more thing that I wanted to mention about recursion is something that is called the call stack. Since now I have coded it up, let me demonstrate you what I mean by the call stack. Let's say I have to calculate something called, let's say, factorial 4. So what is factorial 4? It is essentially 4 into factorial 3. So now what happens is factorial 3 gets called, which is essentially calls factorial 3 into factorial 2. Then factorial 2 gets called, which is essentially 2 into factorial 1. And then factorial 1 gets called, which actually returns 1 because that's how the code is working. So now what happens? Now this thing returns here. This thing returns here. This thing returns here. This whole thing is called something in programming. What is it called, guys? You guys are familiar with this data structure. Some of you are, I think. What is this called? What data structure is this? This is called a stack. Recursion is not a data structure. Recursion uses stack, something specifically called the call stack. Call stack. So a function is kept on another function and it is called. If another function is required, it is put on top of the stack. Ultimately, the stack gets solved one by one. The output of the first element is the input to the next one. So this is the recursion call stack that gets used. So one thing to note here that in a stack, the time complexity and the space complexity is dependent on n, like is dependent on the rate of increase or the rate of decrease of the logic. It may be n, it may be something else, but it depends on the rate of increase or decrease of the logic directly. So it's okay if you did not understand this concept. We will come back to time complexity and space complexity in a future video. But just wanted to mention, it is very good practice to do this recursion on pen and paper and see what calls are happening and where it is starting to get solved. This will give you some visual feedback on how recursion works. Okay. So I'm going to go to a more challenging problem in today's session. So I am going to move out of here and go to Edabit. So I have set the conditions here on medium level and recursion. So yeah, let's pick a problem. Let's try this one, positive integer into base 2, 8, 16. So guys, can you look at this problem and then give me a logic using recursion? You guys have done it in mathematics in your school. What is going to be the logic of this problem? How do you convert an integer to a binary format? Okay. Ravi is saying divide by base. Dharmendra is saying divide by base and store remainder. So should I do it only once or should I do it multiple times, this divide by base and store remainder business? Can I do it once? Yeah, I have to do it multiple times. So let's try to solve it here. Let's try whether we can solve it here for 10 and then we will move forward. So when I have something like 10, so 10 divided by 2 returns 5 and 0. So when it returns 0, I can place it in the end of the stuff. Then I have 5. So recursively, I now pass 5 and 2. Uh, the answer is 2 comma 1. So I can place 1 at the thing and then pass 2 again, which gives me 1 comma 0. And so the whole thing becomes this 0, this 1, and this 1 0. So this whole thing becomes from the bottom 1 0 1 0. If it is not clear, let me do it again with something that is maybe easier to understand. Let's say something like 4. So I try to divide it by 2 and the result comes 2 and 2, basically 2 and 0. And then I pass 2 again, to be divided by 2, and this is 1 comma 0. So I take this 1 0 and then I take this 0. So ultimately the answer becomes 1 0 0, right? So 4 becomes 1 0 0. So I hope this is clear. Once we solve it with the base 2, we will solve it with base 8 and 16. So fine, just run this code once because so these are test cases that Adabit already provides. So let's try to at least print them out. We will only pick one test case and solve it initially. So let's at least print the test cases out and let's see what they are talking about. Okay, so the first number is 10 and the base is 2. The answer is 1010. And we will only focus on the first one, but the third one is also interesting. The number is 102 and the base is 2. So first we are only solving for base 2. Okay. Cool. So what we do is first we divide, let quotient equal to number divided by base, and let us print the quotient, because if the quotient is in decimal, then it's not helpful for us. We want the quotient to be an integer so that we can work with it further. So the quotient is indeed coming in decimal, see, 205.25 and stuff. So not really helpful. So we have to make sure we are only getting the number part of it. So how should we do it? How should we only get the number part of the quotient? Any ideas? And we can also check for the remainder. Remainder is of particular interest here because we will get our answer from chaining the remainder together. Yeah, so remainder is coming out fine. So now I'm interested in how to use the quotient. And okay, so Rohit is saying math.floor, Devkanta is saying parcent. Is it possible? Yeah, I think both might be possible, but parcent we generally do to a string. So math.floor looks to be the better option here. So let's try math.floor with quotient. So we did math.floor. Let's look at how the answer. Cool. So the math.floor got rid of the decimal part of the puzzle and only the integer part remains, which we can pass again with the same base. And we can use the remainder to create the answer. So if you have noticed, the answer is in reverse order. So we'll figure that out. Like basically what that means is the remainder that I get here should be appended at the end. So the logic would be something like return this. Instead of number, we will pass the quotient. And we add the remainder at the end. One thing to keep in mind, if you have noticed, the answer is in string format. So basically we have to convert this remainder to toString. As well as we have to put our boundary condition. So till now we have not put our boundary condition yet. This code will go to an infinite situation. So what is our boundary condition in this case? What is the boundary condition with this particular case? So let's say we are passing 10. The first quotient is 5. Then it's 5 comma 2. So the next quotient is 2. So what should be the boundary condition in this case? Boundary condition, guys. Number by base less than 3. No, I think what you are saying is number divided by base less than base. Is that correct? If the number I have passed is less than base, then I can just return the number, right? If the number is less than base, then game over. I don't need to do all this business. So let me put my boundary condition here. If number is less than base, game over, return number dot toString. Okay, and rest of the stuff, get the quotient, pass the quotient, get the remainder, add it at the end. I think this should work. Let's see. Okay, we made a mistake. Let's see. So let's also print the quotients and the things with this so that it's slightly more clear what we are trying to do. Let's call this Q and call this R, maybe. And then maybe it's slightly more clear what we want to, where we went wrong. Yeah, so the quotient is 5, remainder is 0. 5 comma 2 is called, quotient is 2, remainder is 1. 2.52 is called. So 2.5 should not be called because we are not applying this math.floor where it should be called. We are calling the math.floor while printing it out, but we are not calling it where it is required the most, which is in the logic. So let's check. Now at least some test cases will pass. Awesome. So now we have seen that the test case is passing when the base is 2. Test cases are passing when the base is 8. Yeah. Test cases are not passing when the base is 16. And yeah, only for the base 16, the test cases are not passing. Now what should I do? Base 16. So base 8 and base 2, this problem is working. Base 16 is not working. Because we have to. So let me explain this base 16 business once. So what happens in base 16 is numbers are encoded in this way: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Increase the size a bit. 15. And numbers are encoded as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Is that correct? So in base 16, 10 is denoted as A, 12 is denoted as C, 13 is denoted as D, 14 as E, and 15 as F. So what happens when I have a number, let's say 17, that has to be denoted in base 16? I do 17 divided by 16, the quotient is 1, the remainder is also 1. Okay, and then the quotient is less than, so the output is something like 11. No big deal, can be handled. But if I do something like 31 base 16, the quotient is again 1, and the remainder is 15. So the output is 1F. Is it clear? So in base 16 encoding, 31 is 1F. So how do we handle this situation? So Amar is saying if remainder is greater than 9. Okay. Okay. Only for the cases with base 16, right? If base is equal to 16 and remainder is greater than 9, then do something. What else? And guys, I need string for all of these. Like all of these should be strings: 0, 1, 2, 3. Any other ideas? Guys, any ideas on how to handle this situation? I have an idea. Should I share? Should I go ahead, or you guys want to help me? Okay, so I'm going ahead. I will create another function that takes in a number and a base and returns me the character. Like basically what I'm saying is I will create a function encode number to string, right? Which takes a number and a base, and then returns a string. So where will I call this number? I will call this number. So by default, it's return number to string. Okay. So I will call this number here, this function here. And I will call this function on the remainder. We'll also pass in the bases here, right? So what did I do? I passed in the number and the base to this function, and it will do something and return a string. So right now, if I run it, it will not impact my existing code. It will work fine for, it will work fine for, okay, quotient and remainder. So this I will fix quickly. Actually, I don't need even to fix it. I can call it number divided by base here and number colon base here. I hope by now you understand what is quotient and remainder. So this particular function still works for our bases 2 and 8. I'm just taking the number and returning the string. All I have to do is cover the base 16. So what I can do is, if base equal to 16, then I can do something interesting. I can do some kind of calculation and then return the this characters. Now, can you guys see a pattern here? Like in this characters, for 0 it's 0, for 1 it's 1, for 10 it's A, for 11 it's B. Can I store all this information in a particular data structure? 0 0 1 1 2 2 3 3 4 4. Can I store this in a particular data structure? Any kind of data structure? What will be the data structure for storing this? That way I can save an if else basically. Rohit is saying object, Devkanta is saying hash map. Absolutely. We can also store it in an array, although the information will not be very, very useful. So what I can do is I can store this in an array, let's say base 16 encoding. I can let base 16 encoding equals, and I can put 0 as 0, 1 as 1. Guys, welcome to the boring part of programming. A lot of the times you have to create this kind of stuff, like a mapping which is readable, exhaustive, doesn't miss any edge cases, but it will take you some time to do it. So this is one of those problems. So till 9, we are fine. 10 onwards, we go to this A, B, C, D, E. Finally, 15 is F. Cool. So all I have to do is, if base is equal to 16, I return base 16 encoding, and as a key I can give the number. I've already formatted all this as strings, so I don't need to bother about anything else. If base is 16, then return base 16 encoding number, or else return number to string. Let's try this out. So all my test cases passed. So what did I do in this problem? What is something different that I do in these problems than other problems that I solve every day? What is something different that has been done here? Guys, any observations? Like, what is some stuff that is different? Yeah, Chandan is saying we create function. Yeah. So we created something like an helper function and we put some code in it. Raju is saying no loops, but yeah, we are solving it by recursion, right? So that's why there are no loops. So if we were solving it in loops, then there would be no recursion. And we can, I think, solve this problem in loop as well. We just need a good termination condition. We can run a for loop and solve this problem. Cool. So I think I will end the problem discussion solution for today. So I will stop the recording for this session now. If you have any questions now about MountBlue or any other technical stuff, we will talk about it now. Okay.